Now, so for formulas, see here, first formula is V1 by lambda 1 is equal to V2 by lambda 2. So from where we got this one? This is from refraction principle. Okay, from refraction principle, we got this formula. V1 by lambda 1 is equal to V2 by lambda 2. V1 is greater than V2. V is equal to nu lambda. Keep this in the mind. And V1 is greater than V2. If the light is traveling from rarer to denser medium. Light is traveling from rarer to denser medium. So what will happen now? Y is equal to Y1 plus Y2. Y is equal to what? So Y is equal to A sin omega t plus A sin omega t. It will become 2A sin omega t. Now intensity distribution is what? I is equal to 4 times of I naught. Why? Because I is proportional to amplitude square. So here it will become 4A square. Is it not? So I here, if you take this case, it will become I is equal to 2A whole square. It will become what? I is equal to 4A square. So I is equal to 4I naught. Is that clear? This is how we got the first one. This is what we got from the first one. The second intensity is, so we are writing I is equal to, suppose if the first wave is Y1 is equal to A sin omega t and Y2 is equal to A sin omega t plus phi. I'm not going to solve the derivation. If this is the way, then the intensity I is equal to what? 4I naught cos square phi by 2. Okay, 4I naught cos square phi by 2. This is the value. Okay. So this we can write as average intensity. This value we can write it as average intensity.
Also, what's written after I is equal to 4A square?
Cos square phi by 2. This is for the average intensity.
No, sir, for the second formula.
This one?
No, sir, for the second formula, the last part I'm not able to see.
Okay, the last part it is I equal to 4I naught and I is proportional to amplitude square. Proportional. And I is equal to what? We are writing, here we have 2A, right? So that is 2A whole square. This is the amplitude of the signal. So, or the wave. So 2A whole square. That will become 4A square. So, but what is A square? I naught is equal to A square. Is that clear? So we are writing 4I naught. Is that clear?
Yes, sir.
Now, next is third one. Y1 is equal to A sin omega t. Y2 is equal to A sin omega t plus phi. So we get that is average intensity. Okay. If the value of, if cos square phi by 2 equal to 1 by 2, then what will happen? Then I will be equal to 2I naught, which is also known as average intensity. This is for average intensity, and this is for, this is for the maximum intensity. Average intensity, maximum intensity, minimum intensity is 0. Is that clear? Minimum intensity is 0. Now, going for the next formula, constructive condition for constructive interference, condition for destructive interference, then fringe width, then relation between part difference and phase difference, that we will do. Now here, for Young's double slit experiment, fourth one here, it is Young's double slit experiment. Young's double slit experiment. In Young's double slit experiment, what is the first formula for constructive interference? For constructive interference, or we say bright region or bright fringe, the formula for that is xn is equal to n into lambda capital D by small d. Xn is equal to n into lambda capital D by small d. This is about the constructive interference. Next is destructive interference. Destructive interference or dark fringe. Xn is equal to what? N plus 1 by 2 into lambda into capital D by small d. Constructive interference or bright Xn is equal to n into lambda capital D by small d. Destructive interference or dark is Xn is equal to n plus 1 by 2 lambda into capital D by small d. Where n is equal to what? N is equal to the value of n is equal to what? N is equal to 0, comma plus or minus 1, comma plus or minus 2 keeps on going. Is it clear, all of you?
Yes, sir.
What about you, Dhruti?
Yes, sir.
Now, next one is what? Fringe width. Fringe width is what? Fringe width beta is equal to xn plus 1 minus xn. That is beta is equal to lambda into capital D by small d. Lambda into capital D by small d. So we have Young's double slit experiment, then fringe width formula also, and constructive distance. So we have the relation for x into capital D by small d. 1 second. So here difference relation between phase difference and path difference. Next one. Relation between phase difference small delta and path difference capital delta. What is the formula here? The formula for this is del lambda by 2 pi small delta. Delta is equal to lambda by 2 pi small delta. This is the formula. Relation between phase difference and path difference. Okay. Copy this one. So what did we come across? Number one, if it is a bright fringe, it is 4I0. If it is average, this is. If it is in minimum, it is 0. Okay, this is bright, this is average. We can write here, add up one more value, like for dark fringe. dark or I will be equal to 0. Clear? For dark or for zero intensity. For dark, it will be dark fringe or dark region. I will be equal to 0. Intensity will be equal to 0. They can ask this question in multiple choice. What I predict? They can ask this question 1, 2, 3. These questions in your multiple choice question MCQs. What is here? One more formula. Delta is equal to part difference formula is x into, I'll write here. One more. Please add this. Okay. Seventh one. Delta is equal to x into small d by capital D. This is the formula for part difference. X into small d by capital D. I'll write what is small d and what is capital D.
Done, so
Done. This also please copy this seventh one.
copy to
Delta is equal to x into small d by capital D. Good. See once again, this is the formula for refraction. V1 by lambda 1 is equal to V2 by lambda 2. And we are using this formula. V is equal to nu lambda. And V1 is greater than V2. That is rarer medium to denser medium. The second one is Y1 is equal to A sin omega t, Y2 is equal to Y is equal to A sin. Both are same. Add both of them. So you get 2A sin omega t. The intensity is what I is equal to 4 I naught. And here I is proportional to A square. So I is equal to 2A whole square, that is equal to 4A square. And here A square is what I naught, 4 I naught. Here third one, Y is equal to A sin omega t. This is for the bright fringe. For average, because there is some phase difference, means one is ahead and one is behind. In that situation, the intensity is 4I0 cos square 5 by 2. The average intensity is what? Y is equal to 2I0. When cos square 5 by 2 is 1 by 2. And if it is dark, I is equal to 0. Next one is Young's double slit experiment. In that constructive interference or bright fringe or bright zone or bright region, whatever it is, they can use any name. Instead of using bright zone, bright fringe, they can say bright zone or bright region. So don't get confused with the term. So bright region also they can say. So xn is equal to n into lambda capital D by small d. What is here n? N is a number. I'll just explain that how it comes. Capital D is the distance between the slit and the screen. Small d is the distance between the two holes, two slits. Okay. Small d is the distance between two holes. Capital D is the distance between the slit and the screen. So this is the condition for constructive interference. This is the condition for destructive interference, and we have the values. We can start from 0. If it is 0, it is central fringe. If it is 1, 2, 3, 4, it is you are moving ahead from the center. You are moving ahead like that. Next is fringe width formula. Distance between two thickness of one fringe or distance between two consecutive bright or dark fringes. That is known as fringe width. So the formula is lambda into capital D by small d. Now relation between phase difference and part difference. Lambda delta is equal to lambda by 2 by small delta. And here one more formula here. This is a formula for path difference. X into small d by capital D. What is x? X is the distance from the central fringe to that fringe. Okay. Please copy this one. Then we'll quickly move to diffraction formulas and then we'll start numericals. So the first I started with the difference between interference pattern and diffraction pattern. That I have sent the picture to you. Are you done with this?
Yes, sir.
No. Now I'm going with the diffraction formula. So in diffraction formula, 8th one. Diffraction formula, what did we do? Sin theta is equal to what is the formula? Yesterday we did, right? Is equal to theta is equal to lambda by a. Theta is equal to lambda by a. So here for secondary maxima, for maxima condition is what? For maxima, you want to find out maxima, the condition is theta is equal to n plus 1 by 2 into lambda by a. And for minima theta is equal to n into lambda by a. N is equal to plus or minus 1, plus or minus 2, plus or minus 3, keeps on going. So these are the formulas, okay, almost 8 formulas. So mostly they are asking question on this particular concept. 1, 2, 3, 4. They're asking, and this also. They're asking questions on 4, 5, 6, 7. These formulas they are asking. So definitely one question will be there for 5 marker question. You need to solve that. Okay, so quickly we will start with the textbook question, example question. Then we can enter into the into the exercise. So I'll start the example question 10.3, page number 366. Example question 10.3, page number 366. Come on, start that. Start the first one. Again.
Moldy.
Once again, I repeat, this is a numerical like slit separation is given as 2 millimeters. Distance between slit and observation screen is 100 centimeter. Part difference is, we don't know. Wave arriving at a point is 5 centimeter away from the center. Okay. So what is this? This is small d, right? This is what is it? Big D, capital D. And what is part difference symbol? Delta. Okay, waves arriving at a distance x is equal to 5 centimeter. What is the formula for part difference?